Okay, here goes take 5 on how to use my esoteric sequencer software that I've been developing over the course of this year. It's called KWARC. I'm presenting this video in something of a tutorial format because there's a closed alpha test going on right now, and I didn't provide these lovely people a README or any technical documentation on how to use this software, and it's not very self-explanatory yet. So as well as showing the wider world what I've been up to, I hope this video helps them make some music with this thing. It's a standalone piece of software. It's not a VST. It's not a DAW. It doesn't synthesize any sounds itself. It's just a MIDI generator. And yeah, you're going to want to pipe this into your DAW or through some hardware or something like that so you can actually get some sounds working. So before we go any further with the software, let's just quickly set that up in Ableton Live. If we go to the preferences, just for the output ports, you'll see KWARC here. Just make sure track, sync, and remote are all ticked. There is some input functionality as well. We're not going to worry about that in this video today, and it's not fully implemented yet anyway. So just make sure those are ticked for the outputs. If you're using something like FL Studio, there's going to be some equivalent process. I'm not sure what that is. Also, if you're using Windows, you're going to need to install loop MIDI because Windows doesn't have any virtual MIDI ports, which KWARC relies on when it's talking to, other pieces of software. It's a tiny piece of software, loop MIDI. You'll be prompted to download it. Don't worry about it too much. The last thing you'd want to do, which I'm not going to do right now because it will screw up the audio recording for demo purposes, you'll want to click your external sync button right here. So this will sync the BPM and the start and stop, but because I'm going to be starting and stopping a lot as I record this, yeah, we're just going to leave that unticked for now. So let's actually take a look at the KWARC software. We're not going to be looking at Ableton anymore, so we can press Command F11 to full screen. In Ableton, I've just got a few basic things loaded up. A drum kit, a few Serum presets for an electric piano, bass, that sort of thing. And here is the software itself, or the sequencer itself. So like I say, this was take 5. This was the song I just sequenced in about 2 minutes before I realized that the audio wasn't recording properly. Oops. But this is actually kind of beneficial. So let's actually just go through with this pre-made project and see what we've got. I'll hit play and we can hear the full thing. So it's nothing groundbreaking, but I think we can all agree that's a perfectly cromulent piece of, 120-something dance music, kick drum, floaty lead things. Great, perfect. This looks like a lot going on right now, I'm pretty sure. But we're going to break things down. We're going to look at it piece by piece, and we're going to see what's going on in this project. And then we're going to create a new project after that. And yeah, we'll see how we can build one up from scratch just very, very quickly. So first of all, let's just take a look at the drum sequencer because I'm pretty sure most people watching this video will have seen some kind of drum sequencer before. So I'm double tapping or double clicking on this generator header here. We call each of these panels, these vertical panels, these are called generators. And yeah, as the name might suggest, the drum generator is mostly used to sequence and generate drum parts. And that's what we've got going on. We've got a kick drum, as you can see, snare, clap, open hi-hat, closed hi-hat, crash. These are actually just default channel names. You can reassign, rename these as you like. You'll notice that the sequencer is also in hexadecimal. So each of these hex digits represents a velocity. 7F is the highest velocity you can get, 7F equals 127 in decimal. For various display and data entry reasons, we're having to use hexadecimal for a few things. It's just a quirk to get your head around, I'm afraid. But if you're familiar with trackers and things, you've probably seen it before. Let's just solo this this drum sequence apart so we can hear what's going on. Okay. So you'll see that there's each of these channels has its own playhead, which is represented by a white highlight in the square. The snare has a very simple, just short loop, whilst everything else has a longer loop. Goes for 8 beats, the snare only goes for 2 beats. This is hopefully quite self-explanatory, just seeing what's going on here. Again, if you use some kind of pattern sequencer before for a drum sequencer, this shouldn't be too far out of the ordinary. So let's now take a look at the particle generators, and really these are the things that make KWARC unique. So these are, if I zoom in to these are simulations of general subatomic particles using Crank-Nicholson simulations. Don't worry about it. You don't need to know anything about quantum mechanics or wave functions, or you don't need to understand any of that. Frankly, I don't have a background in quantum anything, so it doesn't matter. All you need to understand are that these things are probability distributions, right? Let's turn that particle off so we're just looking at the one. We've got a red particle right here. In the top display, we've got various notes. Let's zoom in. We can see F3, G sharp 3, C4, F4. And underneath these notes is a probability distribution. So let's say we were just to trigger a note right now. Then it's almost like a bell curve we can see, right? So it's most likely going to be a C or an F that gets triggered. And so then, there's a chance of a G sharp or G sharp 3, G sharp 4 being triggered. And quite rarely you'll also get an F3 or a C5 because these are at the extremes. When we hit play, you'll see this particle begins to simulate. And that process I just talked about of notes being triggered happens. There you go. The particle disappears and it collapses down into a single note. And then it will respawn at some point in the future. And all of this triggering and collapsing is being triggered by, influenced by the main pattern sequencer, which is represented right now in a tape at the bottom. Yeah, cool. We can turn this one back on. You'll see this is a green particle. Great. So red particles react to red notes. Just have a look down here at this cell. We've got red values, green values, and blue values. Same effect, whatever. The red cells affect the red particles in all of the particle generators. The green values affect the green particles. And if we go over to this base part here with the blue particle, as you can probably expect, blue values in these cells affect blue particles. There you go. Oh yeah, I'm wondering why it's not doing anything. It's because it's muted. So let's turn the bass on as well now. So we're getting some interesting rhythmic counterpoints musically here, because the keyboard's being triggered by red and green particles, but the bass is being triggered by blue particles. And none of these necessarily need to land on the same note. Okay, let's just add the synth back in right here. Cool. let's now dive a little bit deeper into what's going on. So just, again, purely focusing on the particle generators, this is what a brand new project looks like. In the pattern sequencer, you can see it's completely empty. There's no notes being written in the top here. This is where you write notes, A, B, C. There's no notes in the note cells, and there are no color values in the red, green, blue color cells. So if we hit play, nothing happens. There are no notes drawn over the top of this particle generator here, or this particle simulation. That's now up to us to write some notes. So let's start just by writing a 1 chord, okay? We're in C major. You can see your key signature down here, C major. And let's just type a 1 chord. So we click the note cell and we just press the number 1. And it automatically enters the notes C, E, G, which is a 1 chord for C major. And you'll now see these notes have appeared above the particle simulation, C, E, G. I hit play, and the simulation moves around underneath these notes. We can increase the length of this simulation. At the moment, it'll last for 4 beats, or 1 bar in 4/4. But our default pattern is 2 bars long. So let's set this to 8. And now you'll see that simulation will last a little bit longer. It's also traveling through one side and then coming back through the other side. So these are periodic boundary conditions, or Pac-Man rules, as I prefer to call it. You can make the particle reflect from the wall by clicking this button right here. And now it will try and bounce off the edge of this wall. Let's make it start a little bit closer to the wall. And you'll see it reflects kind of weirdly. This is expected. This is... we're only seeing, mathematically, we're only seeing the complex half of this simulation. We can see the real half if we wanted to instead. This is a very, very subtle difference. Don't worry about it too much. But this is how we can influence our particle. We can spread it out a bit further if we want to. We can make it more massive. So these peaks in the probability distribution are closer together and it travels slower. We can make it less massive. So it'll the peaks are much less concentrated, close together. And yeah. We can increase the velocity, so it'll travel a bit quicker. Which again, if we turn the mass down, that then becomes very apparent. Just play around with this stuff. You don't need to know. You know, it's you can't go wrong. It's designed for you not to go wrong. Don't worry about it. Just mess around. Do what looks pretty. Have fun. Well, let's now actually make this trigger a note. So to trigger notes, we want to write in the color cells. Okay. Let's zoom all the way in. So this takes values from 0 to 127, where 0 is nothing, okay? We can just press R, and that'll randomize the note, or the value in this cell. We can also press Shift and M to type in the maximum value, which is 7F, or 127 in decimal. And we can press M without the shift to type in the lowest non-zero value, which is just 1. If we type in 0, it just resets the cell to nothing. You can also type in backspace, and that'll clear the cell. But let's type in 7F, and let's zoom out again. So, at the maximum value of 7F, 127, this will guarantee that a green particle will collapse when the playhead reaches this cell. And there you go. And then that note is held until the pattern ends. You can set the velocity of the note here as well. Again, hexadecimal, so let's do 7F. Now it's higher velocity. You can lower velocity. You can press R on any field and you'll randomize the value like that too. Great. So that's how you control the basic note parameters. Let's say we now want to stop this note. So we can type in an X right here. And you'll see this displays a bit differently. It'll write an X into the field, and it'll draw this little colored bar above the cell. And this signifies a note off. So if I now hit play on the sequencer again, you'll see that this particle respawns after the playhead reaches this X. We can then type another note on top of this X. So let's do another 7F. So this particle will now collapse once and play a note from the available notes here. It will respawn when it gets to this cell right here, and then it will trigger again, where it will be held until the end of the bar. So let's do that. There we go. That's exactly what happens. And we can, again, stop this note by putting another X right there. Okay. So you can highlight multiple cells. If we click on this green cell and then drag, it's highlighted every single green cell along the way. We can randomize the content of these cells, you see here, by pressing this random button, and we can change the amount or the number of cells that are filled using this amount slider. So if I just click rand right here, yeah, it's generated a few notes for us. If we turn the amount all the way up and click rand again, you can hear it's considerably busier. We can also randomize the chords that we generate. So here I'm clicking and dragging. So I've highlighted all of these note cells now. And again, I'm going to click this random button, or I can just press R again, the R shortcut to randomize the content of the cells. Okay. There's a lot of different chord sequences and changes here. So let's turn the amount down and hit rand again. Okay. Great. And let's say we want to randomize everything that's in this cell. So if we command and click, or control click if you're on Windows or Linux, you'll see we're now highlighting the entire cell. So all of the color values and all of the note values. And we can change the amount, click rand again. And let's add another couple of particles into here. So let's add a red guy and let's add a blue guy. And then let's just hit play. There you go. It's very quickly generated a musical phrase. Let's now just try and make something a little bit more interesting. So let's go for a, I don't know. I say a bit more interesting, I've just put in A minor as a key. Whatever, let's write something in A minor. We'll hit randomize again. It will automatically transpose the chords and everything. But let's just get a different phrase going on, why not? And here's what we have. Okay, let's add another particle generator in. And this is sending on MIDI channel 3. It says MIDI channel 2. Again, we're in hexadecimal here. So this is MIDI channel 3, indexing from 1 to 16, 0 to F. Again, it's a little bit of a quirk, but it's something that just has to be adapted to, I'm afraid. Great. So I'm literally just adding random stuff in at this point. Don't gotta worry about it. Let's mute these chords. So this is a 303 clone. That's what this is mapped to. So let's set the number of voices down to 1. Add a couple of new particles in. Change the range of available notes. Yeah, interesting. Anyway, that's something for you guys to experiment with, or at least people doing the alpha test right now. Finally, let's just get some drums going here. Again, let's keep it really simple. So we've clicked the label here next to the kick drum to highlight everything, and we're just going to click this fill button here at 1/4 notes at 100 or hexadecimal 64 velocity. Let's just click fill. There we go. Let's get rid of that acid line and bring the other stuff back in, because that wasn't very good. And this is just a drum sequencer, right? Again, you can highlight multiple things. You can press R to randomize the value. That is obviously not a closed hi-hat, so we could rename this if we wanted to. Or we can just change the note. See? I've changed that to a 42, which is general MIDI for a closed hi-hat. There we go. Okay. And I think I'm going to leave it there, just for this little demo. There is a lot I haven't shown. I've not gone through how we can create derivations of patterns and what the template pattern is. I've not gone through phrases or the song sequencer. I've not gone through how to load and blend between two projects at the same time. There's a ton of stuff that I've not covered here, which I'm going to let you people, figure out for yourselves if you're testing this right now. To the wider world on YouTube or wherever, if this is something that interests you, please just let me know in the comments. There will be a closed beta coming up at some point. You can follow me on Instagram, where I post updates on the software. Please feel free to ask questions. There's a lot of things that I cannot talk about in a video like this without going on for hours and hours and hours about the motivations and theory behind this, etc. If you're interested, ask. I'm happy to talk. But anyway, thank you all for sticking around with me and watching this little demonstration. I hope to share some more with you all very, very soon. Cheers, everyone.